All right, here we go. This is lesson 4.3 in Math 7. It is area of a parallelogram. All right, I've got some shapes here. I want to ask you, which ones of these would be parallelograms? All right, perhaps knowing the definition of a parallelogram would help. A parallelogram is a two-dimensional shape with two pairs of parallel sides. So looking at this, we've got, see? If we look here, there's this line segment and this one right here. You'll notice that if you were to extend these, assuming I've drawn this super well, they would never intersect. They would never cross over, which would say that this line over here is parallel. This line segment and that one, they are parallel. So we use these little lines, these little arrows, to say that this one is parallel to this. And then if we look, also this one here, if we were to continue these out as far as they could go in either direction, they would never intersect, which means that this one is parallel to this one. But just to make sure that it's not confusing, one of the sets we're going to put two arrows on, just so that it's clear that this one isn't parallel to this one, or this one to that, or that to that. So each set of parallel lines gets its own amount of these little arrows. Because C has two different sets of parallel lines, two pairs of parallel sides, we can say that this one is a parallelogram. What about B? You'll notice that there's one set of parallel lines there, but this line and this one line, eventually they would cross over, which would say that this is not parallel to that, which means B would not be a parallelogram. D, if we look at it, it's actually basically the same shape as C, it's just been turned. If you took this and turned, you'll notice this is 10 squares tall, 5 centimeters, because this is a special type of grid paper. And then this, it goes up 3 and over 3. So here we have 3, 3, and these are 10, which would tell you that these are actually congruent, which is a fancy word that means that you could flip this and make them interpose. They would be able to fit on top of each other. Now A, you're looking at that and you're like, that's a rectangle. Well, a rectangle is actually a type of parallelogram. Why? Because the top side and the bottom side are parallel, and these ones on the left and the right are also parallel. So this is actually a type of parallelogram we know as a rectangle. A square is also a parallelogram. It's just a type of parallelogram. I've cut out this piece of paper here just to show that C, that shape, if we were to take it and flip it over, we'd be able to make it the same size as D. They're actually the same size, which means that they would have the same area. Now we're going to move on to calculating area. I want to start with a rectangle, and then we'll move on to other parallelograms. Now these little squares are half a centimeter. So if we count them, there's 1 square, 2, 3, 4, 5, 6, 7. 7 times a half. Half of 7 is 3.5 centimeters. And then this other side, the height of it would be 3, which 3 divided by 2 is 1.5 centimeters, 1.5 centimeters. Now, this is 1.5 centimeters tall and 3.5 centimeters wide. And we probably have learned in the past that area of a rectangle is equal to the length times the width. Now, the width here happens to be 3.5 centimeters. The length happens to be 1.5 centimeters. So, to find the area equals this length, 1.5 centimeters, times our 3.5 centimeters, this width, length times width. So let's take 1.5 times 3.5 All right, now add it up. Okay, and then we have 1 decimal, 2 decimals. So in my answer, 1, 2, we'd have 5.25. Area equals 5.25. Now this unit is centimeters times centimeters. That's what we've done here. So this should be centimeters, which is known as centimeters squared. Now looking at this here, if we were to count how many of these little squares there were, there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if these were centimeter squares, this would be 21 centimeters squared, but these were actually half centimeters. Every 4 of these is actually a centimeter squared. It's 1 centimeter by 1 centimeter. So there's 1 centimeter squared, 2, 3. We have 1, 2, 3, 4. That would be another centimeter squared. 1, 2, 3, 4. That would be another centimeter squared. And then we have 1/4 of a centimeter squared. 1/4 would be a decimal 25, right? So that's why we have decimal 25. So if we count them, we have 1, 2, 3, 4, 5 and a quarter, 5.25 centimeters squared. It would have probably been easier if I didn't use decimals of centimeters. All you need to do and remember is multiply your length times your width, and now we know how to do that with decimals, so you can do that to figure out your answer. I'm going to do a simpler example here. We've got this rectangle. It's 2 centimeters wide and 3 centimeters tall, so we know that the width is 2 centimeters. We know the height is 3 centimeters, or the width or the height or whatever you want to do. We know the area is going to be this times that, so it's going to be my width times my height, I'm calling it now. Why? Because I'm imagining this is like a picture of maybe a building or something and how tall it is. If you want to use length or interchange them, that's fine. Left to right, when you're looking at it, is normally width, and then you can either do height or length depending how you're looking at it. So area here is going to be my width, which is 2 centimeters, times my height, which is 3 centimeters. And we're going to get area is 2 times 3, which is easy, 6. And the unit, centimeters times centimeters, is centimeters squared. So we found out our area was 6 centimeters squared. And if we look at this, we've got 1 centimeter squared there, 2, 3, 4, 5, 6. There's 6 centimeters squared. Now what about a parallelogram, one that isn't a rectangle or a square? Now looking at this, remember each of these squares is half centimeter, so we've got half, 1, half, 2. So this bottom part here, it's 2 centimeters, the base is 2 centimeters. But looking at this side, it's not easy to measure this because we don't really know how much it is when it's going on this angle like this. But what we do know is how tall this object is. Okay, so I'm going to choose this spot here. It's 1, 2, 3, 4, 5, 6 halves. 6 times a half, or we could count it half 1, half 2, half 3. The height of it, the height is 3 centimeters. Now you might notice that those numbers are very similar to these ones we had up here, and I did that on purpose. Why not color coordinate? Blue is the base, and H, the red, is the height. Now I've colored something here yellow. It's actually a separate little piece of paper that fills in this little spot over here. Check out something here. If I take this section of this area, and I move it, I'm not getting rid of it, I'm just moving it, and I move it over to the other side, stuck to my finger, you'll notice that it makes a rectangle. You'll also notice that that rectangle, it's the same size as this rectangle up here. What you can do with parallelograms is look, and you'll notice that you can take part of it and move it over to make it into a rectangle. which will make the calculation easy. You'll notice if I cover up this spot over here and try to make it not seen, we've got 2 squares here and 2 squares here, which would make 4 squares, which is 2 centimeters, which would just be our width. And then you've got your height here, which is still 3 centimeters. So our area for a parallelogram is actually almost the same as our one for our rectangle. We just need to remember that the height is not the sides of it that are kind of hard to measure. It's actually just the straight up and down, the perpendicular line from our base. Notice it's at a right angle. So to find the area, we take our height times our base. So area is, height is 3 centimeters. Base was 2 centimeters. Area is 6 centimeters squared. And what we could do is go through and kind of count up all these portions of squares and all that, and it would take a little while. Or we can just try to imagine and move it over that way. Let's do some examples. All right, here's one. Count how wide it is. It's 1 centimeter wide. Okay, its base. If this is a parallelogram, which it is, and that's 1 centimeter, then our base would be 1 centimeter. Now, what would our height be? It's got to be a perpendicular line to this baseline. Okay, so if I take one of those corners and I count down, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are half centimeter squares. So what's half of 10? It's 5. So my height is 5 centimeters. My base is 1 centimeter. That means that my area is height times base, which is 5 centimeters times 1 centimeter, which would be 5 times 1 is 5 centimeters squared. My area here is 5 centimeters squared. Sorry, I haven't been putting boxes around. I'm going to do an example that doesn't have, using these actual squares. I'm going to write in different measurements, and it's just going to be a scalar. All right, we've got this shape here. It's a parallelogram. The height is 100 centimeters, and the base is 12 centimeters. So area is base times height. This is my base. This is my height. So area is 12 centimeters times 100 centimeters. Area is 1200 centimeters squared. Now this video, I haven't been super neat with my writing because I've been using this pencil crayon and I can't find my sharpener. One thing, on a formula that you'll be shown often on quizzes would have A equals BH. Just remember, B variables right beside each other means multiply them. So that's what I've been doing up here. But this is what you'll see. Area equals base times height. So finding the area of parallelograms is a lot like finding area of rectangles and squares. There's a couple different ways you can kind of imagine it in your head, but you'll find that you just need to find that base and that height and then multiply them.